Far from the warmth of the sun, at the very edge of the solar system, lies a world locked in twilight, a realm of eternal frost and whispering winds. Here, beyond the orbit of Uranus, drifts Neptune, the blue giant. Its deep sapphire clouds swirl in endless storms. Encircling it is a moon unlike any other, Triton. At first glance, Triton seems a world of silence, an icy sphere shrouded in nitrogen frost, suspended in the distant dark. But beneath that stillness lies a story of violence, mystery, and cosmic defiance. For Triton does something almost no other large moon dares to do. It orbits its planet backward. While nearly every major moon in the solar system moves in the same direction as its planet's rotation, Triton travels the other way, retrograde, against the flow of Neptune's spin. This single fact transforms Triton from a simple satellite into a profound enigma, a clue to the solar system's ancient past and the forces that shaped its outermost frontier. The story begins in 1846, when Neptune itself was first glimpsed through a telescope. Just 17 days later, British astronomer William Lassell peered into the darkness and saw something extraordinary, a faint point of light moving near the planet's edge. He had discovered Neptune's first and largest moon, Triton. At the time, no one could have imagined how strange it was. For decades, all we knew of Triton came from the faint light it reflected, hints of an icy surface, a distant, frozen companion to a distant, frozen world. Only in the late 20th century would humanity truly see Triton for the first time. In 1989, NASA's Voyager 2 spacecraft swept past Neptune, sending home the only close-up images we've ever received. What it revealed astonished scientists: geysers erupting from beneath the ice, nitrogen frost plains stretching for hundreds of kilometers, and vast frozen basins scarred by ancient tectonic flows. And above all, Voyager's measurements confirmed what had long been suspected: Triton was orbiting in the opposite direction of Neptune's rotation. This was not a coincidence. It was a revelation. In the vast family of moons across the solar system, retrograde orbits are rare. Most moons form from the same spinning disk of debris that surrounds their parent planet, inheriting its direction of rotation, prograde motion. But Triton moves against Neptune's spin. Each day on Triton, if day can be measured at such distances, is a slow backward dance through space, the moon moving clockwise while Neptune rotates counterclockwise. Such motion is dynamically unstable for a large moon. It cannot have formed where it is. Something must have placed Triton into this strange orbit, something dramatic, something that rewrote the history of the Neptune system. The key to Triton's retrograde motion lies in its origin story. Triton, scientists now believe, did not form around Neptune at all. It was born far away, a wanderer from the Kuiper Belt, the region beyond Neptune filled with icy remnants from the solar system's creation. Long ago, Triton was likely a dwarf planet, perhaps similar to Pluto, complete with its own small moon. Then, billions of years ago, destiny intervened. As Triton drifted through space, its path crossed Neptune's. Captured by the giant planet's gravity, Triton was pulled into orbit, but not gently. The encounter was catastrophic. To be captured, Triton had to lose a vast amount of energy. One theory suggests that as it passed near Neptune, it interacted gravitationally with its own companion moon. The smaller moon was flung away into the void, while Triton was trapped, enslaved by Neptune's gravity. Its orbit reversed in the process. Over time, tidal forces circularized its trajectory, pulling it into the nearly perfect orbit we see today. But the scars of that violent capture remain, both in Triton's motion and in the devastation it likely caused among Neptune's original moons. Triton's arrival would have been an apocalypse for Neptune's ancient system. Before Triton, Neptune may have had a family of moons orbiting peacefully, much like Jupiter or Saturn. But when Triton was captured, its immense mass, nearly that of Pluto, wreaked havoc. Its gravitational influence would have destabilized and destroyed the pre-existing satellites, scattering them into space or smashing them into each other. The small, irregular moons that remain today, Procuse, Nereid, and a handful of others, are likely the survivors of that cosmic upheaval, remnants of a shattered original system. Thus, Triton is both intruder and heir, a usurper that annihilated what came before, only to become the jewel of Neptune's domain. Its backward orbit is the quiet testimony of that cataclysm, a frozen echo of a time when chaos ruled the outer solar system. Though frozen and distant, Triton is far from dead. Voyager 2's images revealed a landscape alive with motion and renewal, cryovolcanic plains, geysers venting nitrogen gas, and ridges that hint at internal activity. Triton's surface, one of the youngest in the solar system, shows few impact craters, evidence that it has been reshaped again and again by forces beneath. Despite temperatures near -235 degrees Celsius, Triton's interior may still harbor liquid water, kept warm by the constant kneading of tidal forces. Every orbit, Neptune's gravity stretches and compresses the moon's interior, generating heat through friction, a process that may sustain subsurface oceans, much like those believed to exist on Europa or Enceladus. In this frozen twilight world, there may yet be warmth, and where there is warmth, there is the potential, however faint, for life. Triton's orbit not only moves backward, it is also tilted, inclined about 23 degrees to Neptune's equator. This means that Triton experiences extreme, century-long seasons as the sun's light sweeps across its polar regions. During its long summer, sunlight may trigger geysers that vent nitrogen gas into space, creating thin, transient atmospheres that collapse again when the cold returns. The dance of frost and gas, solid and vapor, continues in slow motion, a rhythm of ice and sunlight, echoing through the centuries. From this vast distance, the sun is merely a bright star, yet even here its faint energy shapes the face of a world. But Triton's fate is written in its orbit. Because it moves against Neptune's rotation, tidal interactions between the two bodies cause Triton to spiral slowly inward. Each passing millennium brings it a little closer to its planet. In perhaps a few billion years, Triton will cross Neptune's Roche limit, the point at which tidal forces will tear it apart. When that happens, Triton may become a ring system, a majestic, icy halo circling the blue giant. A fitting end for a captured world, once a wanderer, then a moon, and finally, the ringed adornment of the planet it could never escape. Triton's story, like all cosmic stories, is one of transformation. Nothing in the universe stands still forever. No spacecraft has visited Triton since Voyager 2's fleeting encounter in 1989. But new missions are being envisioned. Proposals to send orbiters or landers to study this mysterious moon up close. NASA's Trident mission, if approved, could fly past Triton in the coming decades, probing its thin atmosphere, searching for magnetic fields, and hunting for signs of a hidden ocean beneath the ice. Such a mission would not only explore a single moon, but unlock clues about Kuiper Belt objects, about planetary capture, and about the potential for life in the coldest corners of the solar system. Triton, once an intruder, could become a key to understanding how planets and moons evolve, and how chaos can give birth to stability, even beauty. Triton is a contradiction. It orbits backward, yet its motion tells the forward story of cosmic evolution. It is frozen, yet active, captured, yet commanding. In its icy surface lies the memory of a violent past. In its retrograde path, the signature of a solar system still in flux. Every time it circles Neptune, moving against the current of its parent planet's spin, it reminds us that nature is full of paradoxes, that what seems impossible can, in the vastness of space, become real.